Kelsey, an OpenSciEd teacher and facilitator. This is lesson 6 in unit 6.2. It's the end of the first lesson set in this unit. We work with some really important concepts, and there's a really great check-in point to individually assess your students' progress. So let's dig in. So in lesson 5, the previous lesson, we investigated where the water droplets on the outside of a cold container come from. And we figure out that water comes from the air, not inside the cup. This builds on and reinforces some really important concepts from lesson 4, where we figured out that liquids and gases are made of particles and that systems can be open or closed. So in this lesson, we're going to try and use these things we figured out to explain the observations we made about the effect a lid has on the matter in the cup system. This is a putting the pieces together lesson. It takes 2 days. It's a 45-minute prep for this lesson, but I did put a star there. I'm going to go over a couple things about that towards the end of this video. We do have hands-on investigations, we do not require devices, and we don't have any videos for this lesson. Here's the lesson at a glance. In this first chunk, we start by connecting a manipulative we used previously to a new one we're going to use in this lesson. Then we explore how liquid, gas, and solid particles interact with that new manipulative. We also learn a new skill, diagrammatic particle models. From these, we figure out that solids are also made of particles. Solid particles do not have a lot of space between them, and this keeps liquids and gas particles from going in between those solid particles. In this next chunk, we come together in a science circle to define what we now know in a way that we can use to explain what's going on in different systems. We figure out that we can use models to explain what's happening to particles of solids, liquids, and gases as they interact. And then we use all these things we have done and created on a formative assessment for feedback. Then we navigate to our next lesson by exploring questions this has brought up for us. So we figure out that liquids, gases, and solids are all made of particles of matter. Particles in a gas have a lot of space between them, but particles of liquids and solids do not. They're closer together. Liquids and gases are made of particles that can move around freely, but solids are made of particles that cannot. We're left wondering, how do liquids change temperature even when they are in closed systems? I'm going to show you some key moments of this lesson. First, the navigation part of this lesson is really important. We start by asking students to recall the chip activity from lesson 4 in the picture at the top. This is where we modeled water particles evaporating. Then we ask students to what they think would be happening at other parts of the cup system, parts that include the solid cup walls or lid. This is where we explain to students that solids are also made of particles. We use this cup that's cut in half with magnetic marbles representing the particles to show students how those particles are kind of stuck together and that there are many, many layers. From this navigation, we're ready to move into some hands-on exploration. In part 3 and 4, we model the matter movement in the cup system. Groups use magnetic and non-magnetic marbles on a metal sheet pan to show how particles of liquids can move, evaporate, and leave an open system, but cannot leave a closed system. That's the picture on the left. Then we introduce diagrammatic representations of particles. This is the first time we're having students practice this. It is scaffolded. We begin by examining the space drawn between particles of solids, liquids, and gases. And the students work together to explain in words what happens to the interacting particles at different places in the cup system. At the end, they have their first structured practice at actually drawing particles interacting. So it's important to give students the time they need here, but at the same time know that they will continue to practice these skills. In part 5, we come to a science circle and we make sense of all of this together. This is a consensus discussion where we summarize what we figured out in a class progress tracker, and we create these posters that will hang on the wall for the rest of this unit. I recommend not having students fill in their own progress trackers during the circle. I have found that many students end up taking the whole time to copy, and it's tough for them to do that and participate in the discourse. I like to have students summarize their thinking with their groups first so they are prepared to share some ideas in the circle. You can also have them summarize in their own notebooks after the circle. So we create these posters that go on the wall. These are ones that I've created with my classes. I like to ask students to tell me how to draw the particles of solids, liquids, and gases with how much space go between them. That can go on the wall as well. So it's not just in words, but it's in pictures too. So in part 6, we have a formative assessment opportunity. It's called Explaining the Effects of Different Lid Designs. This is an excellent opportunity to individually assess students' progress so far in the unit and provide them feedback. The students plan a hypothetical investigation and construct an explanation for the performance of different lid designs. This is a bigger formative assessment, and I like to focus on the part where we ask them to develop a particle model that shows how structural differences in the cup systems allow water particles to leave the system at some points in the system, but not others, because this is a big performance expectations that we are building towards in this unit. A couple quick material management tips and tricks for this lesson. First is that cut cup with magnetic marbles that we use in the navigation. This is an excellent visualization for students to visualize solid particles. You can't see it in this picture, but these marbles are flat on one side, magnetic, so you can stick them on either side of the cut cup wall that shows that there's multiple layers. You can walk around then with a loose marble and show how that loose marble representing a liquid particle or a gas particle wouldn't be able to get through those many layers of marbles that are stuck together. I keep this visual out for the remainder of the unit. I just have it sitting there for any time I feel like I need to reteach, so students can continue to visualize solid particles. My second and last tip for this lesson is about this marble model showing changes in mass. So depending on your kit, you may need to glue the wooden marbles onto magnets. This is why I put an asterisk at the beginning of this video showing how much time you might need to prepare. So the marbles in this picture, they are magnetic marbles that again are flat on one side. My kit, my materials didn't have these. I was provided with wooden marbles and flat magnets. If you're using this type of setup, then you're going to have to glue those wooden marbles onto the magnets, and this can take time. However, I did this the first time I taught the unit, maybe 5 or 6 years ago, and I haven't had to do it again. So only if you are just doing this the first time will it take more time. But a tip for that. If you're using these magnetic marbles that you've glued together, I teach my students how to slide them on the metal tray instead of picking them up. If they pick them up, they're going to break. I explain this to students. I say, please move them around and explore with them, but please don't pick them up. They will break. If I hear this sound, click, click, I know they're being picked up. And that usually works great. This second and last tip is something that I'm sure all teachers would do anyway, but have students count the number of each type of marble, the magnetic and non-magnetic, when they get the materials and when the activity is over before they give them back. This will help make sure that you have the right amount on your trays and you can begin in the next class and hand out the materials with the right amount. We do not add any words to our word wall in this lesson. The posters we create are those two that I showed you in our science circle. They go on the wall and they're used throughout the remainder of this unit. And that's the end of this lesson. It's the end of this lesson set. From here, we move on to the next lesson set. We start to explore if matter cannot enter or exit a closed system, then how does the temperature of a liquid change? And we'll look at those in future videos. I'll see you there.